So I would like to provide some additional support on what to do when you get ratios in case the questions did stump you. I'm going to do the example on a supplementary angle and on a vertices. You can apply this to complementary as well. Let's start with the supplementary to make it a little bit easier. So let's say the ratio of angles A and B are 2:3. And you should, if you do get an image, you should get an image that looks something like this. I think that would be about correct. And so angle A would be there and angle B would be there. Now, it would say the ratio is 2:3. So the question is, how in the world do we solve this? The thing is, with any ratio, the important tip is to find what 1 is. All right, that's an important step. You need to find out what 1 is, and then later you could just multiply and find out that what 2 and 3 would be, or what the 2 and 3 are by multiplying them. So just to clarify as well, A will then be the 2 and angle B will then be the 3, okay? So whatever 1 is, A is going to be twice that amount, B is going to be 3 times that amount. Now, let's start by looking at all the parts first. So the other way, also just one thing to add. So let's say angle A right here. If it is 2 parts, that means this section right here, it would have 2 equal angles, right? That's what it's saying. So there's 2 equal angles that make it up. And what it's saying as well is then if you have the same angles and you add them to B, then you're going to get 3 parts of B. But in other words, what they're saying is you're going to have 5 equal parts, right? 2 plus 3 is 5. So the total single parts, 1 parts, there's going to be 5 of them. Now, this should help us find the 1 part because we know that a supplementary angle is 180 degrees. But now let's say we're going to divide it into 5 different parts. So the way that we're going to say this is, let's say we call each of these random angles, let's just call it that symbol that I showed you the other day, theta. Okay, we're going to call it that. It's just like any other letter, but let's say we call that. So if you note, there's actually 5 of these parts, right? There's 1 right by the A there, 2, 3, 4, and 5. So 180 is also equal to 5 of whatever random angle that is. So then if we do our math, do a little bit of algebra, and we divide both sides by 5, then you should be left with, I believe, 36. So 36 degrees is equal to each one of those little parts. Now this is valuable information. This makes life a little bit easier for us because now we get to just plug the numbers in to solve what A and B are. So A in this case would be 2 of whatever that angle is, right? So then if I plug it in, angle A, I don't have an answer for that yet, is equal to 2 times 36 degrees. Now we could easily solve that this is going to be 72 degrees. So angle A is 72 degrees, while angle B is going to be 3 times that angle. And so then if we do the math again, 3 times the same number, 36, right? Because we're taking the individual part. And 3 times that is 100 and, let me get this right, 38. Oh, no, not quite. Oops, 108. 108 degrees. That would be angle B. So now, let's see what this means, all right? So it's saying that you have angle A that is slightly smaller, and it is 72 degrees. And then you have angle B that is slightly bigger, and that is 108 degrees. Does it make sense? Well, we could quickly look at the image to have an idea of this. If I just erase some of the bigger lines there, you could see that A would be a little bit smaller. So let's say we'll just write this down, 72 degrees and then 108 degrees. It looks like it makes sense. So that is your answer there. Okay, so angle A is 72 degrees, angle B is 108. Now you could do the same thing with let's even use the same numbers for this. So ratio of angles A and B is 2/3, but this time we're gonna go with the vertices. So with the vertices, that means that angle A would look something like, I believe something like this. Okay, so this would be angle A, and this would be angle B. Now we're still going with the same question. So actually, let me just write vertices for this one. Or a vertex, I guess. So we could see that angle A is smaller. Same thing, find what one is. So we know that A is equal to 2 and B is equal to 3. And so then same thing, I know that there are 5 parts. And then once I know that there are the 5 parts, then I could just go straight into the math. This time I'm gonna go straight into math, and I'll draw the image later. So we know that there are 5 parts, and there's 360 degrees for a vertex. And so therefore, 360 degrees is gonna be 5 times angle, right? Whatever angle is. So then if we divide by 5, I should be left with 70, I believe it's 72 degrees. So 72 degrees is equal to one of those angles. Again, very precious information. We're gonna keep that. So now I know that angle A is gonna be 2 of whatever that angle is. Plug it in again, 2 times 72 degrees. And that should equal 144 degrees. Okay, so A is equal to 144 degrees. And then as for B, let me write it next to it again. B is equal to 3 times that angle. So then 3 times 72 degrees. And I should be left with 216 degrees. Now, another way to make sure is you could add these angles up and see if they add up to 360. That way I know. But when I look at it, it looks about right. So let me just write it in. So 144 degrees and 216 degrees, which makes sense because both of them are bigger than 90 degrees and A is still smaller than B. So this makes sense. So if you are struggling with those ratio questions, that's how you solve it. If you're noticing, you should actually be able to solve it without even drawing the angles. You're just using the ratios and using a little bit of algebra. If you would still like to draw it to be safe, you could definitely do that. But it is possible to just do the math portion of it once you get the question. All right, if you have any further questions, please don't hesitate to ask. That's it. Good luck.